Hello everyone, and welcome once again to another exercise solving session with Mr. Incongruous. The topic that we will be covering are lists, which will probably go hand in hand with for loops. The usual way to iterate through a list is using a for loop or a while loop, as we have seen previously, even though that is much more clunky to do. So what we will find today will probably have to do with both lists and for loops. Now, without any further ado, let's see what Google has in store for us. Firefox, and now it's about lists. See what we can find. Go with this one. Okay, Python list is the most widely used data structure, and a good understanding of list operations is necessary. Let's go then. Exercise 1. Reverse a given list in Python. Okay, let's go. What we want to do is to take the one in the end and move it to the first place, the second one to the second place, third one from the and the third place, and so on. Now, I think there's one very simple way to do this, which is to sort the list by reversing it, which is I'm gonna go from memory, and we already have what we need. That's one way of doing it, but what I think they're trying to do here is teach us how to use Python logic to go through a list and get the last element first, the second last element second, and so on. To do that, it's good to remember how indexing works with lists. We know that the first position is index 0, index 1, index 2, and so on. And we also know that the last element of a list is index number -1. And it'll always be the case no matter how long or short the list is. So what we can do is use a while loop to create a temporary list. So a temp list, which will be empty. And what we can, my logic is, while sample list has elements in it, we should take the last element, add it to the temporary list, and delete the last element. Iterate the cycle again, take the last element, move it to the temporary list, delete the last element, until we have sample list empty, at which point we will say that the sample list is equal to temporary list. It does the same, exactly the same as sorting it in reverse order, but it helps us chew a bit more on how Python works and thinks. So what I was telling you is that while the length using function len of sample list is larger than 0, we could say while it's larger than 0, while it's different from 0. There are many different ways to do this. What we will do is we will add the last element to the temporary list, temp list dot append sample list -1, so it will add the last element, and then it will go to the first place, and then we will remove sample list dot remove -1. Easiest way to check if this is working, and if it throws error, list dot remove. Okay, we are using value error, list dot remove x not in list, because there isn't a -1 in this list. I was wrong. Remove goes for a particular value, so what we need to use is the other function for removal in lists, which is del. We need to delete sample list -1, and this should work better. As you can see, this is working as intended. 500, 400, 300, 200, 100. I already explained how it works. First, it takes the last element, 500, and it appends it to temporary list, which puts it here. Then it deletes the element, goes to the next element, adds it to the temporary list, and then deletes it, and so on until there are no elements left, until the length of sample list is 0, at which point it leaves the loop and prints our new temporary list. Let's see what the people who made the exercise think about our solution. Okay, let's see. Yeah, it definitely works, but why? I think the third one, so what it's saying is go from the start until the end, going by increments of -1. If I am correct, if we tell it to go by 1, it should just print the list in the same order it's in currently. Yeah, that's the case. And if we add 2, it should be 100, 300, 500. Okay, it's a different way of doing it. I had forgotten about this way of doing things. As you can see, you can include not only a single column to show the start index and the end index, you can also add a second column to tell Python how many steps you want it to take while going through that section of the list. In this case, what it was doing is telling Python to go from the start all the way to the end in increments of -1, which in turn gives this result: 500, 400, 300, 200, 100. Once again, 3 different solutions for one very simple problem. If anything I say in my videos will stay with you regarding Python programming, I think it should be this: there isn't a single solution to a given problem, even when it's a very simple problem like the ones we're seeing here. Now, let's move on to the next exercise. Exercise 2. Concatenate 2 lists index-wise. Okay, my name is Kali, so the element 0 should be concatenated with element 0, element 1 with element 1, and so on. Here, the easiest way would be to use a while loop again. My reasoning is use a while loop that increases until it reaches the length of list 1 -1, because we know that since list indexing starts from 0, if we try to access number 4, it will throw an error because it will say there's no such thing as element number 4 in this list. We only have 0, 1, 2, 3. Okay, we should create a variable that will count the places, that will start from 0, then increase it by 1 each time until it reaches the length of the list -1, and as it goes through that cycle, it says that list 3, it will add to a new list, then the sum of these 2 strings, then the sum of these 2 strings, then the sum of these 2 strings. We will call this new list list 3, which is an empty list. And here we will just call this variable count equals 0, and off we go. While count is less than the length of list 1 -1, we should append to list 3, so list 3 dot append list 1 index position count plus list 2 index position count. This will take the same position both times and add them together and then append it to list 3. After it does that, we should increase count by 1, otherwise we will enter an infinite loop because we will never meet the condition included here. Then count is equal to count plus 1, or if you want to simplify it a little bit, count plus equal 1, which is a special way of expressing variable changes that Python accepts. And finally, to see if everything is working as intended, we should print list3. Let's go. My name is, we are missing the last element. While count is less than length list minus 1, which means when count is less than 3, which in turn means that when it reaches 3, this condition will be false, which means that it won't enter the loop again. There are two possible ways to fix this. The first is to say that while count is less than or equal to the length of the list minus 1, or to say that while count is less than the length of the list. I think this solution is clearer there because it has less symbols to juggle about. And once again, we give it a try. Now it's working correctly. My name is Kelly. Let's see what solution the creators had in mind. These people are definitely using more complex syntax to express their solution. Let's try and see what they meant with these. We have list1 equals list2, list3, I plus j for I and j for this value plus this value for same values in zip, the two lists. Let's find out what zip is. Sorry about that, ladies and gentlemen. Unfortunately, I had a few technical problems with my internet connection and my camera, so I will have to finish this video without a webcam, and it'll probably be the same for the foreseeable future until I can get a new webcam. What we were doing was finding out what in the blazes this zip function means. To do that, we were about to Google the term Python zip, and now that internet is actually working, we can check it out. Python zip function. Zip function returns a zip object, which is an iterator of tuples where the first item in each past iterator is paired together. Okay, if the past iterators have different lengths, the iterator with the least items decides the length of the new iterator. So we can have, let's see, list4 equals 1, 2, 3, list5 equals 1 and 2, list6 equals zip, list4, list5, and let's print list6 and see what happens. We will just print out these so we won't get distracted, and we can actually see what happens here. Okay, it shows us a reference to the object, but not an object in itself. Let's see if we can, let's create a new list, list7, which will be an empty list, for element in list6. Let's append that element to list7, list7.append element. And then we will print list7 just to see what is going on. Yes, we have, it's not exactly the same as we did here, but what it's doing is taking each element in this zip called list6 and adding it to list7. And here we have 1, 1, 2, 2. The reason why it doesn't add a third element is what we saw here, that the zipping will go through only until it reaches the list with the least amount of elements, with the lesser length, if you prefer. Now, if we wanted to use zip and get a result similar to this one, actually, let's use this same list, call them list 4 and list 5. I think we should print element 0 plus element 1, and that means it will take this one and add them together and then append them to list 7, then this one and this one, then this one and this one, then this one and this one. Let's see if it works as intended. My name is Kelly. Yet another way to solve this apparently very simple exercise. I think we're good to go, and we can now start with the third exercise. Exercise 3. Given a Python list of numbers, turn every item of a list into its square. Okay, this definitely needs a for loop. Okay, we have a list. A list equals 1, 2, 3, 4, 5, 6, 7. For item in a list, what we want to do is, I think this will fail, but we never know. I'm pretty sure this one won't work out, but the idea would be to say item is equal to item squared, but I don't think that will influence what's actually on the list. There we go. You might be wondering, then why am I posting this? Because I wasn't sure, and I think I mentioned that the idea of this video series is to help you get better at programming and get better in thinking like a programmer. This means not only getting the right solutions on the first try, but it can also mean being willing to check how things actually work. Even if it doesn't help us in this precise problem, it will, one, tell us a bit more about how things work with Python, and two, it might be useful in the future when we want to do something else. There's a saying that we never fail, we only find things that don't work, which is precisely what we are doing here. To get an actual solution, as usual, there are many options. One is to create another list, which we will call blist, which is empty, and to which we will append item, which is equal to item squared. So first it'll add 1, then it'll add 2 times 2, which is 4, and so on. And then we print blist to make sure it's working. 1, 4, 9, 16, 25, 36, 49. Seems to be working. Yet another way would be to try and change each element in a list. We can do that by, well, we'll remove that. We will change this. What we want to do now would be to create an index variable that will tell on what position we are, and use it to replace the element in a list with its square. How would that look? Let's see. Sample index equals 0. Item equals item 2. We will say that a list position sample index will be equal to item, which is the square, and then we will increase sample index by 1. Sample index plus equal 1. And this, I think, should work. There we go. 1, 4, 9, 16, 25, 36, 49. Once again, different logics behind a solution, but the solution itself is correct. And for the third part of this act, or this tragedy if you prefer, let's see what these psychopaths came up with. A list equals 1, 2, 3, 4, 5, 6, 7. A list equals x times x for x in a list. This way of presenting loops is really strange to me. I'm not going to lie to you, but it works. Maybe it will be more intuitive for you, but in my case it's just plain weird, even though it works. I'm not trying to trash talk or anything. It's just something alien to me. Now, concatenate two lists in the following order: hello dear, which is 0 0, hello sir 0 1, take dear 1 0, take sir 1 1. Okay, once again we have many ways to do it. We could just go list 1 0 plus list 2 0, for example. We could do that for every single element that was asked of us, but that of course would be contrary to the idea of these exercises, which is for us to get acquainted with list indexes, for loops, etc. Okay, how do we do this then? We need to iterate through each element of this list, and then we need to iterate through each element of this list. This in turn means that we must have indented for loops, which will make the different combinations. There is a Python iterator library, but I don't think it's worth to Google it, given that it's a relatively simple exercise with just 4 possibilities in 2 lists. It'll be different if we had 5 lists with 6 elements each and we needed to go through all different possible combinations. Then we would do well in finding out about Python's iterators. But for this, I think a nested for loop would be much quicker. We want a third list to which we will append our different combinations. And now we go for item in list 1, and then we want to go for each item. For this we want to go through here and here, so we say for element in list 2, and we go list, we need to add that combination list 1 and list 2 to list 3. Now we say list 3 dot append item, which belongs to list 1, plus space plus element, and then we'll print list 3, and let's see what happens. Hello dear, hello sir, take dear, take sir. Hello dear, hello sir, take dear, take sir. Let's see what their solution was. My bet would be that it's something similar to this, only in one single line, as is their custom. Yeah, rest list equals x plus y for x in list, for y in list 2. I'm not going to pretend to know what the logic behind that. One day I will have to take and actually go in depth on how these one-line fors work, but for me it's just much more intuitive to have each instruction in one line, which may take more space but makes the code much more readable, at least to my taste. Now we move to exercise number 5. Given a 2 Python list, iterate both lists simultaneously such that list 1 should display item in original order and list 2 in reverse order. Okay, we have list 1 and list 2. Now what I think we should do is simply for each item in list 1 print the item, then print item -1 in list 2, and delete element -1. So then on the next element, Python will print the second element of list 1 and the new last element in list 2, and so on until we finish. Let's check if our solution makes sense. For element in list 1, we want to print element list 2 -1, and we want to delete list 2 index -1. Let's see if this works. 10 for 100, 2 300, 3 200, 4 100, which is exactly the correct solution. Let's see what they say about it. Oh, they're using the zip function. Okay, for x and y, in while it's zipping list 1 and list 2 in reverse order, which we already saw here, print x and y. This is an interesting solution. Okay, remove empty strings from the list of strings. Here what we want to do is, Python doesn't care if we have one list or two lists or whatever, so we will go with the simplest solution, which would be to create an empty list, and we will only append to that list those strings that are not empty. We will go for element in list 1. Now we need an if statement. If we there are different ways to do this. For example, if element is different to a blank list, or if the length of element is greater than 0, it's your choice. But the important thing is to append that element. And we print list 2 to check if our solution makes sense or is correct. Mike, Emma, Kelly, Brad. We're good, and we need to check their solution. Filter function, rest list. Okay, it seems like filter will remove the first parameter in the list that we give it as a second parameter. We can check this by, first of all, list 2 is unnecessary in this case. The result is the same. Let's see what happens if we change none with Mike. Okay, it doesn't work as I thought it did. None. Let's check how the filter function works. Python filter function filters the given iterable with the help of a function that tests each element in the iterable to be true or not. Let's see how this works in practice. Oh, you can create functions that return true or false, and you can use those functions to filter a given list. That's interesting. It seems a bit overkill for this exercise, but again, we are finding out about new functions that may not be very common. To be honest, I had no clue that this filter function existed, but that can be helpful in the future when we want to check and create new lists based on different criteria. This filter function could be extremely useful. We will go with one more exercise and call it a day. Add item 7000 after 6000 in the following Python list. These are two nested lists. We have list 1, integer, integer. It has a second list inside list 1, which is composed of integer, integer, and we have a third list to which we want to append the number 7000. This has to do with indexing. We will start with a simpler list. List 1 equals 1, and another list which we will only have the integer 2. We want to add something to the list that is on index 1 of list 1. So we say list1 index 1 dot append, let's go with number 3, and then we print list1 to make sure everything is working as intended. If it is, it should say 1 comma brackets, because there's a list, 2 comma 3, and then the 2 final brackets, because we're enclosing this into list 1. Let's see. 1, 2, 3. We should now take it one step further, because we have two different lists here. We have actually 3 lists. The first one, the second one, and the third one. We should append the number 7000 to list 1 first, 0, 1, 2. The second element of list 1 is our first list, and then we have to do the same to see which index position within this list is the third list. In this case it's 0, 1, 2. We can't just go with -1 because we have this 500 here. So list 1 index position 2, and again index position 2 dot append 7000. Let's see how it goes. We forgot to actually print the list, otherwise we can't check our results. Print list 1. 5, 6, 7000, 530 and 40. The solution is correct. Let's see what... Oh, for once our solution and their solution were exactly the same. So this was it for today's session. We've gone through lists. We have learned about a few functions or I should say I had no idea about, which could be useful in the future. And we have also learned a bit how to work with indexing and nested loops. As usual, I'm very thankful for you joining me today, and I'll see you on Thursday with the second installment of our document generator. Thank you very much and happy programming.